Alright, let's get our review on. Don't know how long this is going to take. I'm not going to go too slow on anything. I'm going to hopefully just refresh your memory on most items. And I can't cover everything, but hopefully I'll give you the most bang for your buck, I say. Alright, so the first thing that I want to talk about is variables and types. So when we define something, we need to make a box for it in memory. So if I say int x, I just made a box that can hold an int-sized thing. Okay, maybe it'll eventually hold 42 if I say x equals 42. And there are multiple options for me. So C++ has many types, and we'll eventually learn how to make our own. But it has a lot built in. You have your int, lowercase, double if you like your floating point numbers, your decimal places, char, string, etc. And you can think of every type as like a cloud, right? The int cloud can hold, any int variable can hold whole numbers that aren't too large. So between negative 4 billion and positive 4 billion, 42, 0, negative 7, things like that. And then your double, they can hold your decimal places, 3.14. Also large numbers, things like that. I don't know, 4e to the 100, who knows. And char is your single characters, single quotes, A, B, space, new line, that's one character, just has to be escaped. And then string can hold many things. Lots of characters in between double quotes, A, B, C, things like that. And we just learned about vectors and arrays, and those are also clouds, but they have like clouds inside of clouds because you can have vectors of ints, arrays of ints, etc. So you can put a type within a type. What in the world? That's fun. And yeah, just remember that you have options. And once you declare a variable, declaring a variable does not give it a value. Assuming it's a primitive type. It does for strings and vectors, but they're special. Okay, the primitive types like ints, chars, doubles, arrays of anything, what's inside does not get a value. It's a question mark. So like right here in between, oh gosh, go away. Yeah, in between this line, x is set to question mark, not 42 yet. Okay. So just keep that in mind. You got to initialize. Initialize those bars. All right. And that's essentially it. You know what I assume I don't have to walk you through how to write a program because you've included IOStream so many times. You've made main functions enough. Let's talk about library functions. So the whole point of library functions are people wrote stuff for you, and we're going to use them to do cool stuff. And I want you to remember the anatomy of a function call, right? You'd be like, you say, oh gosh, it's, well, here's the name of the func name. Potentially it takes some arguments. Maybe it takes none, like rand. It takes like arg1, arg2, potentially many, comma separated, and eventually you'll need a semicolon. We'll put it over there. And you can potentially get its result as well and put it in a value. Okay? So you got the function's name, you give it arguments. We call them arguments, like you're arguing with the function, like you're haggling over how much it costs for it to do this thing for you. Alright, and you can possibly store the return value. And even though functions won't be on your test, I hope that you've watched the lectures from about functions, because now you understand like the concept of giving back an answer. Sometimes it doesn't do this. It makes no sense to assign to the result of a function, but sometimes it does. Okay? And that's the idea. So how do you call a function? How do you use its result? That's the idea there. And now let's just go through a few different libraries and see what we have. I did make you a cool cheat sheet, and I'll show you that in a second. Let's do CMath. All of them are essentially the same. cstdlib, you can remember to seed your random number generators and all that, but let's just do some simple things like this. And of course, you're going to have access to this during your test. So double click, be like, there's a cosine function that's specialized for doubles. Take a double, return a double. We know what all this means now that we watched the function videos, so it's going to help us on this midterm, even though we're not testing you on functions. It's beautiful. Got a nice little example. Yeah, so you just include CMath if you want these cool functions. So let me give you some examples, and also let me put up here that the code that I write will be inside the, I don't know, what folder should we call this? We can call it Midterm 1 folder, or Midterm 1 review, inside of our code from class. Okay, so let's say that. So let me hold myself to that. Let's go to code from class, go to CSCI 40, go to Midterm 1 review. Alright, so let's go inside of that folder now. And vim, what do I want to call this? Just libraries. That's EPP. So you know the basic boilerplate of all this stuff. Include iostream using namespace standard. Main, maybe we can talk about command line arguments in a little bit. Return 0, because main returns an int, gives back its exit status, and 0 means it was successful. Exist. Exit. Oh no. Exit code means that main finished successfully. And main is really your program. Finished successfully. Okay, so that's that, and let's include our first library. So CMath, for example. Oops, let's put this above here. We can do cool stuff like, I don't know, see out the cosine of 0. 0.0 or 0, doesn't really matter. Plus 1, or plus 42.34. What is the answer to this, you might ask? Well, let's go and compile it. And remember how to compile things. We are reviewing, so I'm going to put it up here. Compile with. This should probably be muscle memory by now. C++, or G++, standard equals C++ 17, libraries, .cpp, and we want it to be called something other than a.out, so we'll call it libraries. And that's how we'll do it. And let's get a nice terminal in the proper place. cd dot slash csci 40 slash midterm 1 review. Alright, now we're ready. I can copy and paste this if I'm careful. Beautiful. Dot slash libraries. Hey, 43.34. So that's essentially library function calls. This one gave back an answer. Cosine 0.0 returned a double that I can then do stuff to. I can add. Okay. There we go. So you get all these nice functions inside of CMath that do stuff for you. Somebody implemented this stuff for you. It's super nice. Square root, fun stuff. Then let's talk about strings for a second. The string library is a mighty beast. And another good way of studying is like practicing your Xylabs, things like that. Going over the book. So you have some nice options with strings. There's some functions that exist outside of strings, like s2i, and then you have functions on strings themselves, and we call those methods. We'll talk about that more in depth later, but you gotta say, if you have a string s, you gotta say s dot size, and you gotta use the dot, like which is weird because, hey, there was no dot involved for cosine, but strings, you act on them, in a sense. So, the size method, we call it a method instead of a function, or a member function. Don't worry about the terminology right now. Think of it as a function. It works. It acts on S itself. So you can say s.size with no parameters, or no arguments, and somehow it knows to figure out the size of s. What? That's kind of cool. It's a function that acts on a variable. So yeah, strings are special. It's of size 5. Okay, sure. And remember how you can get a string. You just make space for it, and you use cin. So you can give a little cute prompt, be like, enter a word, please. Then you use cin, and it'll get a single word. It'll get a single int, a single double. Okay, that's not too bad, I hope. And yeah, you have a lot of stuff you can do with strings. You can like figure out where places are in them, find content, and I'll just give you an example of that. You can consult the lecture for the rest. And you can be like, see out. Let's see if that thing has, if your string had an f in it. S dot find f. So what does find do? Well, SDF, JKL. Okay, what does find do? It goes and looks for the index of a certain string, and we just gave it a single character as a string, but it gave back the index of that thing for us. So 0, 1, 2, 3 was where the f was. That's quite nice. Okay, what if it's not there? It gives a very large number, which can be converted into -1 or string npos. So it's probably easier to say, hey, was it there? If you remember that from your Xylabs. Otherwise, you could print, yeah, there was an F. And maybe we really wanted that F. I don't know, so sad face and happy face. Okay. Oh no, what have I done wrong? Oh, I forgot a semicolon. That was a syntax error. Just, sure, I did that on purpose, just to test you on that term. Enter a word, please. ASDG. ASG. There was no F. ASDF. There was an F. Okay. So, that's fun stuff, and I encourage you to look up this library. Be like, this is how it works. This is an example. The example is probably more intuitive, and it would make more sense to look at that, but you can do whatever you want. This is your studying time. Alright, so that's library functions. And I did start conditionals already, but let's go head first into them. And so I have made you a beautiful, beautiful cheat sheet. And I worked so long and hard on it. And I use colors, and I hope it is all correct. Please yell at me if you see an error. But I show you all the stuff that I drew in class before for an if statement just by itself. There's code before and code after. How does that actually run? Well, the code before gets run, then it checks the condition, sees if it's true, executes the body if so, and once it's done, it goes to after. And if not, it jumps straight to after because this condition wasn't true. There's no need to go and check anything. There's no need to execute the body because it was only supposed to happen if the condition was true, and it was not. Okay, so that's an if state. And yeah, if statements require conditions that have Boolean values. So Boolean valued variables of the bool type, the bool cloud, true and false. Well, that's all it has, in fact. Deep down. How can you produce a Boolean value? Well, you can check for equality, or some kind of relation between two numbers, two strings, perhaps. I forgot to show you string comparisons, didn't I? Let me do that. String S3, or S2, I guess, equals S plus hi mom. And so you can add strings together, S2, and you can also compare strings for lexicographic ordering. We see out, hey, is ASCII less than JKL? And the answer is true, and it'll convert that to a 1 or a 0. These should actually be strings for reasons. And so I'm going to do that. Let's make sure that they're strings. Let's see here, and I think I need to put it within parentheses as well. There we go. Now it should be happy. And so you can add stuff, you can compare strings for dictionary ordering. But really deep down it's using like the ASCII table, so technically like capital letters come before lowercase letters. But you can look that all up. Yay, and it was true, so it outputted 1. 1 for true. Alright, now back to conditionals. So true and false, these operations you can check for equality, like, hey, is the string's third character equal to, I don't know, H? And this will return true or false depending. And S, remember, strings and arrays, it has made up of maybe these 3 characters, A, S, and D, like I was typing in. Remember that the indices of this array are 0, 1, and 2, so you go at 2, you get the third character. Remember that. And then you can combine things with and, or, and not. Not takes a false, makes it true, and vice versa, or returns true if anything is true that you give it, like X or Y. It's true if one of the two is true. And is true and false otherwise, and is true if both of them are true, false otherwise. Okay, you can go back and look at the tables for those if you'd like. So that's nice. And yeah, so let's talk about conditionals now. You give it a condition, that's a Boolean valued variable, and you can do one of a few things. You can just go straight to the body if the condition is true, and then go to the rest of the code. Otherwise, if the condition is false, you do nothing. So let me show you that. Call it conditionals.cpp. So we'll say like if, I don't know, 3 is greater than 2, see out what? So that's a single if statement, and then you can do it if it's true as well. So this body will never happen, by the way, of course. And then if 2 is less than 3, yes, the rules of the universe make sense. New line. What? Is 3 greater than... Oh, sorry. I'm supposed to do that. That's what I meant. This makes sense. So, sorry about that. But you get it. This will always be false, this will always be true. You could have just as easily replaced this with false. And this with true, but usually you'll be using variables, of course, and this will change over time. Alright, so that's a single if statement. And then, of course, you can do one thing or another using an else statement. You can chain them along like this. So if the condition wasn't true, it was false, you can do the body of the else statement and then continue the program. Okay? That's the idea. That's the difference. If 42 is greater than 43, cout 42 is greater than 43. And of course that won't ever happen, so we'll hit the else case if we include one. Else cout 42 is not greater than 43. Yeah. And then, just to make it non-symmetric, I'll use an endl there. And so we hit the else case. Right? And of course, we can chain these some more using else ifs. Okay, and you can have as many else ifs as you want. I'm just giving you one because it's hard to draw. But the idea is whichever condition is true first, you do its body. And if none of them are true, you go to the else. And of course, the program continues afterward. So execute the body of the first condition that's true. Otherwise do the else. Okay. Hopefully that's not too bad. And what this is good for is things like calculating your grades. You have a range that you're checking for, like, I don't know, double score equals, I don't know, 72.5. And it's like if score is greater than or equal to 90, then it's an A. Else if score is greater than or equal to 80, it's a B. Else if score is greater than or equal to 70, it's a C. And so only one of these will ever get executed. You never execute more than one of these bodies. It's just the first one that's true. The first one's true, it's an A. Otherwise, you know it's between 89.999999, so not 90. It's strictly smaller than 90, and greater than or equal to 80, and then it's a B, and so on and so forth. Otherwise, cout not A, B, or C. Okay. And so we'll hit the else if case here for C. Score is greater than 70, but it's not greater than or equal to 80, it's not greater than or equal to 90. And so the order really matters. Yeah, that's that. Conditionals, loops. That brings us to the next page. A while loop is pretty simple. It has a condition. It's essentially, it's very similar to an if statement, right? It just keeps coming back to itself, though. So while the condition is true, as long as it's true, it keeps on executing the body. Keep on going, please. Blah, blah, blah. And once it's done, it finally gets to the rest of the code. If you have an infinite loop, it's never going to finish. It's never going to get to the after, right? And then for loops are essentially the same, where you're just kind of putting what you might put in a while loop in a different arrangement. So you have an initialization that happens just once, then a condition that you keep checking and coming back to, and a body that you keep executing. But in between those two, the condition checking and the increment and the body, in between here and here, along this route, you have an increment statement. So it's like x++, I++, things like that. So keep on updating, and eventually that condition will become false in theory. And so you don't have an infinite loop, hopefully. And then finally, once the condition is false, just like for a while loop, you do the rest of the code. Okay? Hopefully in this color-coded format, and just explaining it one more time, it's all sinking in. Okay. Let me just show you simple examples of that. Loops.cvp. So we have, I don't know, let's just print from 1 to 10 with a while loop. Int I equals 1, while I is less than or equal to 10. So I is going to range between 1, and it's always going to be less than or equal to 10, we're going to say. So it's going to be 1, then 2, then 3. And we're going to have it go one at a time with I++. And we'll see out I. Oops. Maybe a space. And at the very end, we'll output a new line. Okay. There we go. 10 all in a row. Then we can do the same thing. How about backwards for a for loop? So for loop is very similar, but again, you're kind of putting this and this up in the for loop before the body, if that makes sense. So it's, for certain kinds of loops, it saves thought. Like you're just doing the iteration part all in one line. So you say for int j equals 1, or let's do from 10 down. J greater than or equal to 1, j minus minus. And of course, minus minus is just equal to j minus 1, or j minus equals 1. Either way. We'll see out j in a space. Oops. And then we don't need to take care of changing j. We've done it up here already. And then we can output, I don't know, lift off. Line. Okay, so that'll count down. Yay. Hopefully that all is making sense in your mind. Come to office hours before the midterm if it's not. Okay, hopefully this will be helpful for you. I think it's really nice to be able to know how to do like this flowchart form of things. It really clears up what happens when these things execute. So hopefully this is helpful for you. I had some fun making all those colors. All right. What do I want to do now? Really the last thing that I want to talk about is arrays and vectors. But before then, we got to get through nested loops, of course. So nested loops, they multiply work and try all the possibilities. So let me give an example of a brute force algorithm. All the ways to make change for $1 using pennies, nickels, dimes, and quarters. And so the way that we'll approach this is we'll have 4 separate variables, like how many pennies have we used? Num pennies, num nickels, num dimes, and num quarters. And see how many we need to make $1. And we'll just try all the possibilities between 0 and 100 pennies, 0 and 20 nickels, 0 and 10 dimes, 0 and 4 quarters, yeah? Because we don't want to go above $1. It makes no sense to go to 100 quarters if we just are looking for $1. So let's see all the different ways to make $1 out of coins. We'll forget about the 50-cent piece for now. Sorry, 50-cent piece. Let's see here. So for loops is probably the easiest way. So you keep track of how many things you want, and we'll just nest these loops, and we'll get all the possibilities. So for int num pennies, I'll just call them pennies. It's easier for me. You can have between 0 and 100 pennies. Maybe we had all of something else. Less than or equal to 100 pennies plus plus. And then you could have anywhere between 0 and 20 nickels, right? Because otherwise, if you went more than that, you'd go over $1. Dimes equals 0, dimes less than or equal to 10, dimes plus plus, and then finally, quarters equal to 0, quarters less than or equal to 4, quarters plus plus. So now we need to figure out how much money we just spent. So inside of the innermost loop, we have some values set for all of these variables. And the idea is, because of the magic of nesting loops, we'll have tried all the possibilities. Every possibility will happen once, so let's figure out the price. So the price of our current coins is, let's see here. Or honestly, we can use ints. Price equals pennies plus, or pennies times 1, if you will. Let's see here. Plus nickels times 5 plus dimes times 10 plus quarters times 4. That's the number of cents. That's our price. And so if we hit 100, I guess. Let's call it cents. Check if we made exactly 100. 100 cents. So that's $1. So if cents is exactly equal to 100, we'll print out our combination. You can make $1 with new line, see out, tab over a little bit, pennies, space, pennies, new line. Now we're going to do the same thing for nickels, dimes, and quarters. Okay, and so it'll output all those things if our cents happen to be 100, and eventually it's going to try them all. So at least in one case, if we have 100 pennies and anything else, we're at least going to output that case. Let's see how many options we have. There's probably a many. I didn't run this ahead of time. It was just an idea I had. Whee! All right, so let's see how many we got. Oh, sorry. This was supposed to say pennies. How about we do how do I want to do this? There we go. Fancy Vim stuff. No. There we go. That was unnecessary for me to put a space and then say more things, but you get the idea. Yay. And because it did this so horribly, I think I'd rather just start deleting. Sorry. There. There. That makes more sense. Okay. Let's see how we can do it. How many options do we have? Oh, we have a few. We have way too many options. Oh no. 70 pennies, 4 nickels, 1 dime. Does that make sense? 70 plus 20 plus 10, yeah? These are all adding up to be right. What's the very last one? Exactly 100 pennies. And it looks like we can't do anything with 97 pennies, or 98, or 99, and no more pennies. It's either 96... Oh shoot. What have we done wrong? No, sorry, this is supposed to be 25. Sorry if you've been yelling at me through the screen. 25. Excuse me. This is why we test things. 95 pennies is the minimum. Then you can use a nickel. Or 100 pennies. 90 pennies, 2 nickels, 75 pennies, and you should be able to have a quarter as well. 1 quarter, 75 pennies, 1 nickel, 2 dimes, and you could make this prettier. If it's only one, you don't have to print the S. That'll be another if statement, but hopefully that's a fun little example there. Yeah. And then finally, arrays and vectors. So, arrays and vectors are just ways to hold a bunch of stuff. All right, so if I make an array equals 1, 2, 3, I'm just holding a bunch of stuff of the same type, just a bunch of ints, 3 of them. And let me get an array and then maybe get the average. Dun dun dun. All right, let's make. How about we get an array from the user? How do we want to do this? Well, it's going to be difficult. Maybe we can do that for the vector part. Let's make a normal array for this one. Equals 1, 2, 3, 4, 5. So that's an array. And let's get the average of this array. So how do we do that? We better sum all these values, sum them, and then we can just start dividing by the size of the vector, or of the array. Okay, so here's how we can do it. We can get the sum, keep track of that, and then go through the array. For int I equals 0, I is less than 1, 2, 3, 4, 5, I plus plus, And so for each index, we can add it into sum. So go into the array at index 0, at index 1, at index 2, all the way, and always add into sum. So now we'll have the sum in sum. And then the average is, well, it's the sum divided by 5.0. And remember, double division. One of those better have been a double. Remember that. All right. See out average. That should do it. And apparently it was 3 because that's the middle value and it went incrementing by 1, which makes sense. Okay, let's do the same for vectors, but now we can have the user give the values to us. We'll first ask the user, how many things are you going to put in this vector? No new line. Size. Get that size from the user, and now we can make a vector of ints that starts out empty. We'll ask the user size times. Alright, so we can do like 4 int I equals 0, I is less than size, I plus plus. And each time we get something from the user, we get a num from the user, cn num. Yeah, we don't have to output anything, it's fine. Get a new number, and add it to the end of the vector v. And if we want to use vectors, of course we have to include vector, just like that. And how do you add something to the end of a vector? You say v.pushback that element. Called it num. Okay. So with that, we now have another vector, and we can print it out, but we want the average. So we can do the sum again. We've already declared sum up here, so we can just reuse most of this. There. You know, let's roll around. Let's do it ourselves again. Let's see here. Sum 2 equals 0. For every value, for every x inside of v, using the fancy notation, for every x in v, add that x into sum 2. And at that point we're good. But, oh no. Do I have the sum properly? Yeah, I think so. Oh no, how do I know my size of my array? Average 2 equals, well, it's sum 2 divided by static cast, because we gotta make a double out of an int. Static cast, how do I get the size of that vector? v dot size. There you go. And then we can see out that average. Alright, so the first time, it'll do the array thing, and then it's going to tell us how big is your vector. Well, I don't know, size 4. And it's got 4, then 3, then 8, then 7. And apparently the average is 5.5. And if we want to do it some other way, be like, again 4. Remember that you can give multiple things to cn. It doesn't really care. It'll just keep on looking between spaces. And so I can give them all at once and get 5.5 again. So I think that's all I wanted to say here. I hope that's a good enough review for you. Yell at me, come to office hours if you have any extra questions. I'm here. But yeah, good luck on your midterm. Obviously that wasn't everything. I can't go over everything at all. But that was a good start, I think. So study hard, good luck, and I'll see you later.